some of the pins are connecting and some of them aren't. All right. So, do I have to turn it on or it is on? Okay, cool. So I and some other people from the mid-boss and some other... Turn it off. So I and some other teachers from the Math Twitter blogosphere, other teachers who are NCTM volunteers through their states or nationally, got a chance to go to Reston, where NCTM is, and work on making some arts, which are activities with rigor and coherence, which really means a series of lessons around a subject that NCTM already had resources for, but those resources were scattered around the NCTM site. So there was a journal article over here, and an Illuminations resource over here, and an Illuminations lesson plan over here, but they weren't together, they weren't coherent. And so we got to go look through all NCTM stuff, which there's a ton of, which was really fun, find something that needed to be collected, and then make a collection. And I got to work on triangle congruence, which was extra fun because the Common Core came out since almost everything about triangle congruence was made, and the Common Core said, oh no, don't do it the way all of the textbooks except that one from Chicago do it a different way. And so you probably haven't had a chance to learn triangle congruence the way Common Core suggests it be taught, which is from rigid motions, right? So two triangles are congruent if you can translate, reflect, or rotate one onto the other. And from that, derive side, 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 and angle, side, angle. I had no idea what that meant when I went into writing this arc. So the group of teachers sat around and tried to figure out, like, what does it mean to prove triangles are congruent using transformations, and not just pick one up and put it on top of the other and be like, look, it looks like they match. And so this art isn't on the web yet. This is like a sneak preview, but if you want to tweet at me at MaxMathForum or email me, max@mathforum.org, I will give you links to the Google Docs that are going to go onto the web so that you have a chance to see it. The way that the arc works, so we start with, here are weird shapes. Find one line that divides them in half, and then explain how one half can be mapped on the other half. That's a math teacher in the middle school article. Then we do a pretty standard introduction to the triangle congruent shortcuts, where you think about if two triangles have all the same sides lengths, are they congruent? And the kids draw every possible case and test them and figure out the transformations to get one case onto the other. Then we play a game where, tell me stuff about your triangle. If my triangle matches yours, I get points. The fewer things I am told, the more points I get. And then there's another round of the game where your partner tells you stuff about the triangle and you try and draw a triangle that doesn't match theirs. And then the last round of the game, you ask for 3 things about their triangle. If you can draw a triangle where all those things are true that isn't congruent, you win that round. So a good player would ask for 3 angles on that round, or maybe 2 sides and an angle if they're really good. But then the last lesson of the arc is where things get new and Common Core interesting. So the kids have been all through the unit describing how to translate one triangle onto the other. So in the last game in this series of games, 3 people at your table, you're in a group of 4, 3 people at your table have triangles in front of them. And there are facts about those triangles. So in one round, all of the side lengths are measured. And all those people tell you is, all the sides of our triangles are congruent to each other. So side A is congruent to side B is congruent to side E, and side C is congruent to side F. The person who has no triangles in front of them has to tell their partners how to transform their triangles onto each other. So they might say, okay, do a translation, and they have sentence prompts. Do a translation so point A lines up with point B. And some people do that, and one kid might be like, okay, I'm done. My triangles line up. But your other 2 partners are like, what are you talking about? My triangles don't line up yet. So then you have to think, well, is there a rotation that might make these triangles that I cannot see line up? Is there a reflection that might make these triangles that I cannot see line up? And the reason that game is doing what the Common Core wants you to do is because a transformation proof is about saying there exists a transformation from this triangle to this triangle if we know these things are true. So if you can tell me a transformation without seeing my triangles, that will always get one triangle onto the other, then we know there exists a transformation from here to here. And so then you play the game, you get good at the game, and then it actually takes you through the steps of writing a transformational proof. So if you want to kind of pilot that for us before it goes on the web, tweet me at Max Math Forum, or write to me, max@mathforum.org, and I'll get you the Google Docs, and you can be the first users, and we'll put your feedback into it when it goes online.